All right, Harmony Science Academy. We're going to be looking at polynomials today, okay? But the CBA was a little intense for some of you guys, so let's cover the warm-up. Okay, this question here, and again, there was more than one question that a lot of you guys felt overwhelmed. You feel a little cheated, but you must understand that everything we've learned in the past, it's expected that you still have it somewhere in that brain of yours, okay? So even though it's not part of a review, if it's been covered anytime this year, okay, or really anytime in the past years, okay, it's fair game, okay? So anyways, as we work these out like the other ones, ask yourself, have we seen that material? If we have, then it's fair, okay? Anyway, so number 10, I'm looking at the CBA 8, and I'm wondering what could have caused some of you guys problems, okay? So number 8, what we would have done is just understand this is an exponential. So we want to introduce the logarithm, right? So we're going to go log base e, okay, of e equals log base e of 15, okay? The other way you guys could have written it, which is equal, okay, but a lot more practical, would be this, right? Log base e is natural log e, natural log of 15, okay? So long story short, this cancels, and we have x minus 3 equals natural log 15. We're going to go ahead and add 3 to both sides, and x equals natural log 15 plus 3. Okay, so let's take a peek. Natural log 15 plus 3. Okay. All right. So, and of course, we've seen natural log. So, if you're honest, this is something that we've definitely covered. Okay. All right. Let's look at this scenario. Okay. Now, I'm going to write it in two ways. Okay. I'm going to write it in a way that is new, all right, for us to look at, but because you guys are algebra experts, this should have been one approach. Why? Because you guys have algebra, right? And you know you're supposed to isolate the logarithms. But since this was way different than what we did, a lot of you guys would probably be upset this way. So one thing you could have done is looked at this subtraction of logs and understood you could have used the quotient property. So you have log 4x over 13 equals 0. Okay, this is definitely something you guys were capable of doing. Then in this case, we would introduce, since it's a logarithm, an exponential, base 10. Okay, since here we have a 10, we get the awesome cancellation, and we get 4x over 13 equals, right, this is from some of your math classes in the past, any base to 0 exponent equals 1, and from there we can proceed to solve, right? We're going to multiply by 13 both sides. We're going to divide by 4. Okay, so we end up with the solution for this problem. Okay. All right. So let's go ahead and move forward here. Okay. Now, today's purpose is to really get comfortable with polynomials, which are very important moving forward. And you're going to see things like, how do you name polynomials? Okay. This one has a degree 2. Okay, so this is a quadratic. It's got 3 terms, so it's a trinomial. Okay, a quadratic trinomial. This one has 1, 2, 3, 4 terms. Okay, after 3 we just call them polynomials. Degree 5. And as you'll learn today, this would be a quintic polynomial. Okay, just a lot of vocabulary, a lot of details to get us introduced to this material. So anyways, they're going to be asking you for the maximum number of terms. Okay, then you'll be asked to sketch the graph. You'll also be asked to state the number of real zeros and to approximate those zeros. Okay, so let's go ahead and do 2 here together. Now of course we have calculators, so we'll go ahead and enter them as such. And as far as what we've been asked to do, we can see that this graph, right, it's going up and all of a sudden it turns, goes down. That's 1, goes down, then turns, goes up, 2, down, 3, 4. These were all turns, right? So it turned here 1, 2, 3, 4. Okay. We're going to notice also that we have a 0 there, a 0 here, and a 0 there. And this one's roughly -2, about 1, very close to 2, about 1.8, 1.9. Okay. So if we look at the solution, max number of terms 1, 2, 3, 4. Number of real zeros 1, 2, 3, and we'll be asked to identify those zeros. So -2, 1, and 1.8. Okay. So anyways, we do the same thing here. Follow the graph from left to right. Okay, we're going up, we turn. Okay, so it looks like we have just one max turn. All right. As far as zeros, we have 1, 2 of them. And what are they specifically? -3 and -1. Okay, so let's check. 1 turn, 2 real zeros at -3 and 1. Okay, so it should be a pretty smooth day. Let's go ahead and take care of business, and we'll talk to you in class.